Okay, so here's an introduction to enlargements on the Leaving Cert course. Okay, so what I'm going to do, enlargements is when we are changing a shape to make it look bigger or even smaller as well. Okay, the important things when we're drawing enlargements is we must know the center of enlargement. Where does it get bigger from? Okay, so here I'm going to do an example where I'm giving you a center of enlargement of O here. We're going to make this bigger. If I make it twice as big, we call that a scale factor of 2. If we make it 3 times as big, we call it a scale factor of 3. So scale factor, how many times does it get bigger? If the scale factor is a half, it gets smaller. Quarter, it gets smaller again. Okay, so it's half the size, scale factor of 2, twice the size, etc. So here I'm going to use a scale factor of 2, okay, and draw this triangle from this center of enlargement. So what we do is we get our ruler out, we draw lines from the center of enlargement through the corners of the shape. So if it's a rectangle, you have 4 lines to draw. For a triangle, it's got 3. Now, if it's a scale factor of 2, what's going to happen is this distance is going to be doubled. Okay? If scale factor of 3, that distance is going to be trebled. Okay? So I'm going to draw lines first. There's 2 ways you can do this. I'm going to do it with a compass. You can just measure the line. However, it gets a bit tetchy because for me that's 4.2 something centimeters, right? So I'm going to use a compass. You can just double it, right? So I'm going to draw the lines first and then come back to how I'm going to do the actual construction. So I'm drawing lines through each corner from the center of enlargement. Because it's a scale factor of 2, what I'm going to do then is I'm going to measure with a compass O to A, right? And I'm going to double that length by just putting the pin at A and doing a notch there, okay? So that point is going to end up there. I'm going to do the same for, let's do B next. Go with the alphabet, why not? Mark it on the line. So that distance is doubled, right? At O to C, okay, that distance is doubled. So if it was a scale factor of 3, we'd treble the distance. We do another notch on this line, but I would say the scale factor of 2. And then what we do is we just join them up basically. So wherever that crosses that line, draw a line. Okay, so this triangle is twice, this length is twice the length of that length. That's what it means, scale factor of 2. Normally you notate it with a dash, A dash, B dash, C dash. And we do need to revert back to our knowledge of similar triangles. So similar triangles are the same shape, but enlarged or shrunk down. So if I said to you now, for example, you know the scale factor is 2. If I said to you that was 4, the corresponding side here is this one, an A dash to C dash. You should know that's 8 now because it's doubled, okay? B, C, let's say that's 4.5, that's 9, etc. Right? So the scale factor is linked to the length of the sides. Right, so for this one, same thing again. This time, the center of enlargement, sorry about that, focus camera please. The center of enlargement, so I've got a rectangle. The scale factor I'm going to do this time is 3. The center of enlargement, COE, is at A. So the center of enlargement is one of the corners of the original shape. Okay. The method is the same though. What we do is we draw lines from the center of enlargement, which is A in this case. And it's okay, you will have shapes that overlap sometimes. So the enlargement of this is going to be over the original shape. So I've drawn lines from A through the other three, so extending this line basically. It's a centre of enlargement, it's a scale factor of 3, so I'm going to do B first. Right, so we've got, that's 1, so I'm going to treble that distance, right? So what I'm going to do here is just move this along, so that's twice as big, now it's 3 times as big. Okay? I'm going to do the same for A and D. Okay, so now it's twice as big, now it's 3 times as big. And then I'll do the same for AC. Okay. And then we draw the bigger triangle. Now this is not a triangle, it's a rectangle. Okay, focus camera please, Bond, behave. Right, so I'm going to label this B dash, this is going to be D dash, this is going to be C dash. Sorry about the camera guys. Right, so let me draw. Should be straight up there. Should end up the rectangle again, obviously. Okay, so there it is there. Next scenario I'm giving you is, I'm giving you a shape, triangle, and I'm giving you a bigger triangle. So I'm giving you an enlarged triangle. I'm not giving you the point of the centre of enlargement. So this is how to find the centre of enlargement. So we basically, all we're doing here is working backwards, right? So I know this corner corresponds to that corner. So what I'm going to do is draw a line through. I know this corner corresponds with that corner, so what I'm going to do is draw a line through there. And where they cross over is the centre of enlargement. Okay, so that's how we find the centre of enlargement. If you want, you can do the third one. It should cross over. Yeah, it does cross. Yeah. You know, but you don't need to do 2 really. Okay, so how to find the centre of enlargement, we basically work backwards. We draw a line from the corresponding corners through till we get a crossover point. Okay, so here's a bit of a link between the area of the enlarged shapes and the scale factor, right? So I'm going to take the basic square, size 1 by 1, the area of that is 1, isn't it? So we call that the original shape, the scale factor is just 1. If I double that, the square is going to have sides 2, area 4. So scale factor 2 gives me area 4. Same again, treble it, scale factor of 3, area 9. Scale factor of 4, area 16. So have a think there for a second. Can you see a link between the scale factor and the area? So if I say a scale factor of k, you might have noticed that 16 is 4 squared, 9 is 3 squared, etc. So if I have a scale factor of anything, the area of the enlargement is going to be k squared, okay, times the original one. So it's k squared times the original area. So scale factor of 4 is 16 times 1 in this case, right? Scale factor of 3 is 9 times 1 in this case, right? So if I have a shape here, triangle, let's say, area 5 and I double it, okay, if I double it, the scale factor is 2, isn't it? So it's going to be 2 squared, which is 4 times the original. So the area of this one's going to be 20. 4 times 5, 20. So 2 squared times the original.